of amines, and there we have seen that there are preparations in which you find mixture of all amines are obtained, primary, secondary, and tertiary. Like when you react ammonia with haloalkanes, we get a mixture of primary amine, secondary amine, tertiary amine, along with the quaternary ammonium salts. And industrially, when you do the ammonolysis of alcohols in presence of the alumina or thorium at high temperature, thorium dioxide, we get a mixture of primary, secondary, and tertiary amines, and in that reaction, quaternary salts are not obtained. So in that case, how to separate these mixtures? Of course, this is not being given in your book, but we can separate the mixtures by physical means as well as chemical means. Okay. Separation of mixture can be done when you prepare in bulk. So in physical process, you need not write it. So we can do it by fractional distillation. Fractional distillation. And by chemical process that can be done only when you go to separate a very small amount of the mixture, because otherwise the process will be very, very costly. So one is called Hoffman method. In Hoffman method, we react this amine with diethyloxylate. With diethyloxylate is the ethyl ester of oxalic acid. And in that case, the primary and secondary amine forms different types of products. Tertiary amine does not react. And on the basis of that, we can separate the mixture of amines. And second method, it is there in your book. It's called Hinsberg method, but that did not mention anything about the separation of amines. They have used it for identification of amines. Hinsberg method. In that case, benzene with benzene sulfonyl chloride.
That is nothing, it is a business day.
With benzene sulfonyl chloride. Okay. Here also you'll find the primary and secondary amine reacts, tertiary amine does not react, and we can separate it. This I'll discuss later on, okay, in detail. So only thing you should remember that in physical process we can separate by mixture by fractional distillation, and that two chemical processes are there. One is called Hoffman method and second one is called Hinsberg method. Okay. All right. Now we'll go for the physical properties. Okay. In physical properties, we go for physical state. In the physical state, you'll find methylamine, ethylamine, dimethylamine, okay, gases. All right. Then the other lower alkyl amines are liquids with strong aminical odor. You need to write because the summary that I'm going to send you is it is going to everything will be written. So you don't have to worry. Okay. The higher amines are solids. Aromatic amines lower aromatic amines are colorless liquids, but on wait. While others are solids. On exposure to light, it turns black due to aerial oxidation. Due to aerial oxidation. All right. So this is the physical state. Okay. Now we'll go for boiling points. Boiling points. One. Boiling point of amines are higher than boiling points of corresponding hydrocarbons or alkyls. It is because of the presence of intermolecular hydrogen bonding. So let me write here.
Yes or no? This make it cheap.
Okay, because of intermolecular hydrogen bonding. So, due to intermolecular hydrogen bonding, the boiling point of amines are higher than that of corresponding hydrocarbons or haloalkanes. Oh, I put it in water. Oh. Similar molecular mass. Please write this one. Right. Physical properties takes a lot of time.
Done, sir.
Okay, then right. However, the boiling points of amines are lower than boiling points of corresponding alcohols with similar molecular mass. So I'll show you now. This comes in the exam. They will give you with an example, so you should know. Because boiling points, melting point depends upon molecular mass. Higher molecular mass, more intermolecular force of attraction, and more is the boiling point and melting point. Okay? So let us write example. So we have taken here butane 1 amine, and we have taken here butane 1. Okay, let me calculate the molecular mass. See here. How many carbon we have? 12. Sorry, 4. So 4 into 12 is 48. Then how many hydrogen we have here? 3 plus 2, 5, 7, 9, 11. 11. Nitrogen is 14. How much it comes? 3, 70. Let us see here. Here also 4 carbon. 48. How many hydrogens? 10. See, 3, 7, 3, 5, 7, 9, 1, 10. Oxygen, no, 16. So, 70. Okay? So, almost same molecular mass. Then why the boiling point of butane 1 all is more than that of, much more than that of amine. Okay? So, this is the mass. Okay. Why it is like this? So, I write down the question. Why is boiling point of butane 1 ore more than butane 1 amine, even though their molecular masses are almost same. So first you write this question, then you start writing from here. In exam, you don't have to write this thing, right? So first you write this one, after that you write this. Write little fast.
Answer.
Okay. Did you write after writing this question? Did you write this one?
Yes, sir.
Good. So let me relax. So first I'll explain, then you write. See now. I have taken butylamine. So for butylamine, I write shortcut C4H9. না না হলদি ফুল আছে এদিকে তুমি একটু গিয়া দেখিও
আর এইটা আবার করতে লাগে
See, this hydrogen also will undergo hydrogen bonding with some other molecule more. It is, I'm here drawing primary amine. So, in this case, each molecule is going to show you how many hydrogen bonding. Very interesting. 1, 2, 3. Now I'll go for alcohol, butanol. So, see here. Sorry. See here. Here, each alcohol molecule is showing hydrogen bonding, one with the hydrogen, one with the lone. But anyway, this is more. So in that case, boiling point of this one should be more. And why this alcohol is more? See, electronegativity of oxygen is much more higher than that of nitrogen. So in that case, this oxygen hydrogen bond will become very, very polar. That is, this hydrogen is made highly electron deficient by this oxygen. So this hydrogen pulls more electron cloud towards it and makes this bond stronger than this. So the boiling point of alcohol is more. Why? The hydrogen bonding strength of the alcohols are more than that of the hydrogen bonding of amines. Okay? So I'll write now here. This is the answer. You only have to write everything I'm writing, as if you are all Cerelac babies. We'll write now. Oxygen is more always write the answer in simple English. Oxygen is more electronegative than nitrogen. So the oxygen hydrogen bond is more polar than nitrogen hydrogen bond. All right. I'll put a comma. Which makes hydrogen bonding in alcohol molecules stronger than amines. So now you know, last sentence always you know. Last sentence again, just like the judges give verdict, you also write like this. Hence or thus, the boiling point of butanol is more than that of the butanol. So write down after that last sentence, which you are extremely fond of. Right, thus boiling point of butanol is more than that of butan 1 amine, even though they have similar molecular mass. Right, last sentence. বা এমন হতে পারে বন্ধ টাইট করে বন্ধ হচ্ছে না টাইট করে বন্ধ হচ্ছে না Did you write the last sentence?
Yes, sir.
Okay, good. Now we will come to the second part of the boiling point. Okay, right now. For isomeric amines, the boiling points decreases. Boiling point decreases from primary amine to tertiary. This is very interesting. That is boiling point, you find primary amine has higher boiling point than secondary amine, then tertiary. So moment I draw, then you will be able to understand. Okay. So let us go for primary. See here.
কালকে আমি যেতে পারি বললো কালকে আমার ছুটি আছে কালকে লেটেস্ট ইউনিভার্সিটি কাজ তবু করতে লাগবে
See here. In this case, each primary amine molecule is having 3 hydrogen bonding. 2 through hydrogen and 1 through lone pair. Okay. See here. In secondary amine. See here. So here, each nitrogen is having 2 hydrogen bonding. 1 through the hydrogen and 1 through the lone pair. So in tertiary amine. So tertiary amine, see, yeah, very interesting. I know you will not get interested, but I only have to tell you. See, does it have any hydrogen bonding? No. No hydrogen bonding. So in this case, tertiary molecules do not have any hydrogen bonding. So because of that, they have the lowest boiling point. Clear? So please write, then we'll write the statement.
Done, sir.
Right. The magnitude of hydrogen bonding, magnitude of intermolecular hydrogen bonding. The magnitude of intermolecular hydrogen bonding decreases from primary to tertiary with decrease in hydrogen atom. Stop. Right. Primary amine molecules show greater degree of hydrogen bonding while it is absent in tertiary amines. Stop. Hence, boiling point of isomeric amines decreases from primary to tertiary. Okay. Then we'll go for solubility. Okay, we'll go for solubility. Okay. Lower members of aliphatic amines are highly soluble in water. Yes, they associate with water molecules through intermolecular hydrogen bonding. Okay, so let me write. Try to understand this. See, this alkyl group are a part of alkane. So have you seen any alkane soluble in water? Kerosene is not soluble in water. Petrol is not soluble in water. Petroleum wax is not soluble in water. All right. So as the length of the chain increases, this property is called hydrophobic behavior, hydrophobic nature. So as the length of the chain increases, their hydrophobic nature increases, and then it restricts their solubility of amines in water. Can I wrap this portion?
Yes, sir.
Anywhere which you do not understand, immediately tell, huh? This is not a handwriting class. Acha. Then Lavanto, he is having problem because his school's class starts at 7 o'clock. I feel very bad for this fellow. And then I don't know about others. And Onita, though I have not seen her, I don't know whether she is still in the group or not. She is also having class in the morning. She is still in the group. Hello. Drishti? Drishti is there in the group today or sleeping.
Sir.
Hmm.
Sir,
Done, finish.
sir, can you please just read it out aloud? I'm not too sure about the words, some of the words.
I could not understand yet. Tell me loudly. Hello.
Can you please read what you wrote out?
Yeah. Which portion you could not read? Okay, I'm reading from here.
To the bottom.
However, the solubility decreases. Write down. However, the solubility decreases with increasing length of alkyl chain. Okay, that is the length of alkyl chain is increasing like this. Okay, length of alkyl chain. Full stop. It is because alkyl groups are hydrophobic in nature. Alkyl groups are hydrophobic in nature, means they are not soluble in water. And increase in length and increasing length of alkyl chain this property magnifies, means you can write this property becomes more. This property magnifies. That is, their insolubility increases. Okay, and hence their solubility decreases. And their solubility decreases. I did not, you can write here decrease in water. I did not write because I have written already hydrophobic, so water is there. Hence their solubility decreases. Okay. Now finish, then we will write next paragraph. Aromatic amines are not soluble in water. Because aromatic hydrocarbons are extremely hydrophobic in nature. Are extremely hydrophobic in nature. Okay. Now, however, these are highly soluble in organic solvents. However, these are highly soluble in organic solvents like benzene, ether, alcohols, etc. All right.
Thank you, sir.
So now we'll go to the chemical properties. We'll go to the chemical properties. Are you now going to churches? In the morning, do you go? Anyone? Huh? Or you do it from home only?
Sir, from home.
Acha, good. So in that case, tell Jesus to pardon me because I have taken your morning prayer praying time. Oh, okay. So chemical properties. So now we'll write here. One, basic property. So we'll write down here. See, amines are derivative of ammonia. Ammonia is basic, so amines also will be basic. Amine like ammonia are basic in nature. Why they are basic in nature? In nature. These are Lewis bases due to the presence of lone pair of electrons on nitrogen atom. Okay, so how does it look like? See here. So this is the lone pair. This is the lone pair we have. So these are Lewis base because they can donate. Okay, so let us see. See now. Say I have taken okay. This one you are not going to write, eh? This one. See here. This is ammonia. When you add, it forms here ammonium hydroxide. The ammonia gas is highly soluble in water. I told you in solution chapter, they do not follow Henry's law because they undergo association. Then after that, what does it happen? They undergo dissociation. We know in any substance which liberate hydroxide in aqueous solution, these are bases. So this is we already know. So let me write now here for amines. See there, same thing is going to happen here. So I'll write it directly. I know write this step. I'll write it like this. R this and here I write. See, because of that, amines are basic in nature. Okay, then right now. Today I will discuss up to the basic character, then we'll next day in detail I'm going to discuss one whole class. I'll discuss on the factors which control the basicity of amines. You should know for your entrance exam.
Done, sir.
Okay. So now we are going to now revisit our Ionic Equilibrium chapter. Okay. So this one again I'm going to write it here. So I write like this. Now we will try to find out the equilibrium constant. So what should I write now here? I will write here now RNH3 plus and OH minus. And here we write RNH2 and H2O. I told you that we use a huge amount of solvent if I compare with this. Suppose if I have added one mole of substance, okay, 1 mole I have dissolved in 1 liter of water. 1 liter of water means 1 kg of water. Density is almost 1. So 1 kg of water contains 55.55 moles. Out of that, only 1 mole has combined. This is 54.55 moles are still there, unreacted. So in this case, we can consider water to be concentration of water to be constant. This we have learned in our equilibrium chapter. So we'll write here now, because you may forget. Considering the concentration of water to be constant. What I can write now? K into water is RNH3 plus and OH minus divided by RNH2. See dear, this is constant, this is constant. So product of two constant is also constant. So what you write? We know that for that we write Kb. So it is the equilibrium constant of base. And this. Okay. So what we can write now? Higher the value of Kb, more basic the amine is. Try to understand, they are not phrases. Everything don't try to by heart. I told you, no, science is not for by heart. See, when the value of k will be more, when this value is less and this value is more. See, when it can be more, only when this nitrogen has acted as a base and taken H plus ion from water, because water ionizes to give you H plus and H minus. What is a base? Base should react with H plus. So more and more amine react with the H plus ion of the water, means proton of the water, more it can form. That is, if the value of Kb is higher, then the basicity of the amine is more. Now we know we have another type of scale, we call it pKb scale. Okay, so pKb is nothing but log Kb, or pKb is equal to 1 upon log K. Okay, so what we can write? See, now it is inverse. So we can say lower the value of pKb, higher is the basicity of amine. Okay, then you can write it. Lower the value of pKb, start writing. Lower the value of pKb, higher is the basicity of. So up to this much is enough for today. Because if I start now, I have to, it will take 1.5 hours more. That you will not like it. You may revolt also against me. That exploitation is going on. And today is a regular class, you have to give presents.
Thank you, sir.
Okay.
Thank you, sir.
Okay, welcome.
Thank you,
Welcome.
sir.